Hi, I'm Glenn Larson. After graduating from the University of Maine at Orono with a Bachelor of Science Electrical Engineering, I found myself eventually in Florida working 26 years in defense aerospace, retired and ended up in Louisiana. Along the way I picked up an MBA, went to school at night to be a teacher, got a Master of Arts in Teaching, ended up teaching high school math and physics, computer science, and now I'm a master teacher at the Louisiana Tech University in their You Teach Tech program, teaching prospective high school math teachers how to be teachers. One of the things I found teaching high school and at the university level is that students didn't make the same connections in mathematics that I did. And I also found that I didn't have tools, manipulatives for them to use to help engage them in the things I was trying to teach them. So as a result, after a period of time, I developed something we were calling LARSONangles. It's basically a unit circle set and some sets of similar triangles that connect a bunch of different concepts. Over here, we got an example of a similar triangle set. You can see these are all 30, 60, 90 triangles actually. I'm sorry. You can see these are all 3, 4, 5 Pythagorean triple set. And there's enough information on these triangles to figure out the missing information on all of them. This one has no side information, this one has one piece, this one has one piece. But if you're careful about what you do, you can solve all of them. Along the way, kids will learn the proportionality from this triangle to this triangle. You can use Pythagorean theorem, you can use ratio. And then if you're careful about how you ask questions, you can find out about the constancy of side ratios. The ratio of this side to this side is the same as the ratio of this side to this side. Kids will learn trigonometry and they won't even know it. There are several different sets of similar triangles, and then we also have the unit circle set over here. It comes with 30, 60, 90 in both versions, 30, 60 and 60, 30 and the 45, 45. And I will also give you a blank in case you don't want to give them the the leg information. Let them figure it out on their own. We use this to demonstrate pi minus theta, pi plus theta, minus theta, all have the same magnitude, different signs based on x and y values in the quadrant that we're talking about. This unit circle set has interchangeable rings. This one has the actual magnitude values on it. The other side has the quadrant values. This side here has the angle measures in radians, and flip it over, you guessed it, it has the angle measures in degrees. Good. Put it in here straight. I like this one quite a bit because we say this a lot, especially if you teach physics, that the intercepted arc of a central angle equals the angle measure in radians times the radius. So a 1 radian angle should intercept an arc of exactly one radius, and I can show it to them here. It's a lot different than just telling it to them and trying to make them understand. When we rock the radian, they can see it right away, and it's tangible and touchable. Something about these things being made out of wood that makes a big difference as far as being able to feel them and touch them and see them. It makes it authentic. This material here, just to let you know, is a prototype material. Actual production material looks like this. This is the right size and it has the right parts, but it's not the right material. It will look a lot more like this material here in production. And when you get your triangle set that comes with the unit circle set, it comes in one piece like this. Just break it apart, give you a little piece of sandpaper, and you can rub the little nubs off, and you'll be good to go.